Hello friends, I am Rufus, faculty in Mechanical Engineering Department, JNTUA, College of Engineering, Anantapuramu. So today we are going to learn about optimization. What is meant by optimization that we need to understand first. So optimization is nothing but to find out the optimum value for a given function f of x or some function. What is optimum value? If the function was given to find out the minimum value of a function, the value which is obtained the minimum value is the optimum value. If a function was given with to find out the maximum value, then the optimum value will be the maximum value of the given function. So in order to find out this optimum value, we are going to do some different types of techniques using these optimization methods. So first of all, before going to that one, what is unimodal? What is unimodal? Unimodal is nothing but the name itself, it is describing singular mode. Uni means singular mode. So to eliminate the function, we are going to consider a single mode which is useful for eliminating the function of a function and to find out the optimum value. So how we are going to do means, for example, if we consider an interval a comma b, if we consider an interval a comma b in which we need to minimize the function f of x, we need to minimize the function f of x. So what we are going to do means, we are going to draw taking an interval a comma b in which you need to evaluate this function to find out the minimum value. So in this a comma b, if we have evaluated some points at f1 and f2 function at the point 1 and point 2, f1 and f2, and there are three possible outcomes which we are going to see here. The first possible outcome is if f1 is less than f2, if f1 is less than f2, and another possible outcome is if f1 is greater than f2, and another possible outcome is if f1 is equals to f2. So what happens in all these three cases we are going to discuss now. See, first of all, if we consider f1 is less than f2, the interval will be like this. So this is f1 and this is f2. See, the function is to find out the minimum value. The function is to find out the minimum value. See here, if f1 is less than f2, you can see here, beyond the f2, the value of the function is increasing. Beyond the value, beyond the function f2, this is x2, sorry, x2 and x1. So beyond x2, the value has been increasing. It means beyond x2 to b in this area, the function value is a maximum value. So we are going to delete this interval, that is x2 comma b. We are going to delete the interval x2 comma b, and we consider the new interval as a comma x2, a comma x2, where x2 plays a role of b, where x2 is equals to b. Again, we are going to substitute in the remaining interval, and we are going to evaluate the functions. So this is one case if f1 is less than f2. Then if you go for f1 is greater than f2, what happens? f1 is greater than f2 means, see, if you take interval a comma b, if you consider an interval a comma b, and if you evaluate the function at point x1 and x2, the condition is f1 greater than f2, f1 greater than f2. So if you evaluate function f1 at point x1, so this is f1 and this is f2. Since our problem is a minimum problem, that is to find out the optimum value of minimum value, see here the f1, you can see the value beyond x1 to a is the maximum value. Beyond the value of x1 is x1 to a is maximum value. So we are going to delete this interval a comma x1, and there lies a new interval, that is x1 comma b, where x1 is a. This is a new interval. Again we are going to put the function values, and again we are going to evaluate the function at point x1 and x2. And if we consider the last possible outcome, that is f1 is equals to f2, if we consider an interval a comma b, and if we evaluate the function at 2 points x1 and x2, if the value of f1 is like this and value of f2 at point x2 is like this, since f1 is equals to f2. So what happening, beyond a to x1 there was an increase in value, beyond x2 to b there was an increase in value. So what we are going to do, we are going to delete the function, we delete the interval a comma x1 and x2 comma b, and we are going to consider new interval, that is x1 comma x2, which is equals to a comma b. And again in this interval of uncertainty we are going to place another two experiments, and again we are going to solve the problem for finding out the better minimum value. So this is how we are going to solve a function for finding out the minimum value for a given interval. There are three possible outcomes. One is f1 less than f2, another one is f1 greater than f2, another one is f1 is equals to f2. So if we consider, there are many number of methods for solving this optimization techniques. See, we are going to see different types of methods. So one is elimination methods. One type of methods are elimination methods, another one are pattern search methods, so on. There are n number of methods for solving of the optimization problem. So let us discuss one method in elimination method, that is exhaustive search method. That is exhaustive search method. Exhaustive search method. So how we are going to solve a problem in an exhaustive search method? So in exhaustive search method, in exhaustive search method, a problem was given with an interval a comma b. Let us assume it has an x starting and x final point. X starting and x final point. To find out the minimum value. To find out the minimum value of the given function, minimum of f of x. So what we are going to do means, we are going to draw an interval x starting to x final, and we are going to evaluate. We are going to take 8 experiments in this x starting to x final interval, in this given x starting and x final interval, that is see x1, x2, x3, x4, x5, x6, x7 and x8. So there are we have considered 8 experiments in this given interval from x starting to x final. So what happened? This after evaluating the function, the given function, to find out the minimum value of the given function, after evaluating this function in all these 8 experiments, for suppose if we got the values like this, so this is f1, this is f2, this is f3, f4, f5, f6, f7 and f8. If we draw a curve, the curve of coinciding all these points, it will be like this. It will be like this. So what happened, if we clearly observe at these experiments, the function f4 and f5, which are placed at x4 point and x5 point, they are equal, since f4 is equals to f5. f4 is equals to f5. See, the curve at f4 point and f5 point are equal, and f4 is equals to f5. Then what will be our optimum value? Our optimum value is gonna lie between this x4 and x5 point. That is called x optimum point. So in exhaustive method, we are going to evaluate some n number of experiments. For example, in this problem, I took 8 number of experiments. We are going to evaluate for n number of experiments. After evaluating the n number of experiments by taking some step size, we are going to find out 2 experiments are getting the same functional values. We are going to get 2 experiments getting the same functional values. When there are 2 experiments getting the same functional values, our optimum point is gonna lie between these 2 functions, between these 2 experiments, that is called x optimum, and we are going to consider this x optimum, and we are going to evaluate for function f of x optimum. We are going to get f optimum value. This f optimum value depends upon the step size which we are going to consider. So likewise, there are any number of methods to solve this optimization techniques. In elimination method, there is I just took one of the method, that is exhaustive search method, and there is another method which is called dichotomous search method, and there is another method which is called interval solving method, and there is one more method which is called as an Fibonacci method, which depends upon the Fibonacci series, Fibonacci series numbers, and another method which is called as an golden section method. So there are n number of methods in solving the optimization problem. It depends upon the methodology which we are going to take for solving the function f of x. So in this class we have discussed what is meant by optimization. So if there was a given interval, what are the possible outcomes we are going to get? That is, one is f1 less than f2. If we got f1 is less than f2, you can see here the value, it is from x2 to b, it is increasing because we have considered the minimum value. So the interval from x2 to b is increasing. We are going to delete this interval and we are going to consider the new interval, that is a comma x2. And another possible outcome is f1 is greater than f2, and you can see beyond x1 experiment the value has been increasing between a to x1. We are going to delete this experiment and the new interval is x1 comma b. And another possible outcome is f1 is equals to f2, where you can see beyond x1 and x2 the value has been increasing, and between these two experiments lays the optimum value. So we are going to delete this a to x1 and x to b, and we are going to consider the new set of experiments, that is x1 comma x2, new set of interval, that is between x1 comma x2. So likewise we are going to solve for the optimization problems. In this today class I have taken an example of an elimination approach of exhaustive search method. In exhaustive search method we are going to place n number of experiments. At some particular experiments the function value will be equal. After finding out these two functional values where they are equal, we are going to, there lies in between these two functional values or between these two experiments lies an optimum value. That value is considered as the x optimum value in case of the exhaustive search methods. Thank you.